There are 2 points to tonight's homework. Determine the two qualities of an irrational number. After we've done that, we're going to estimate the square root of different numbers to the nearest tenth. No calculators. So to start, let's find the worksheet that you need to fill out for the homework. Go to my home page, Algebra Documents. Our new unit is Pythagorean Theorem, Radicals, and Real Numbers. I'll give you a few minutes to fill out number 1. Feel free to pause the video now. Alright, I assume you've done that. Let's go on to number 2. This will take a little bit longer, and yes, I want you to write down every single digit that appears on your calculator. Hit the pause button now. Alright, now that you've filled out everything above in the gray columns, let's move on to step 3. Hit the pause button again. Now if you notice, let's not worry about these yet. If you notice all of the numbers that you did not circle, there's a lot of digits there. But it turns out your calculator actually doesn't have them all. Let's pretend you just had a pretty simple calculator. If we were finding the square root of 2, you just get 1.41. Now let's imagine that you can grab the right side of the screen of your calculator and stretch it to the right just a little bit. A few more digits would appear. What if you could grab the screen and drag it even more? Even more digits. How far could I drag this screen? Well, let's see what this says. Wow, we can notice numbers getting more and more digits here as I go to 8, 9, 10 decimals. At some point though, Excel is going to get tired and won't be able to calculate any more numbers. And you'll tell that because a bunch of zeros will start to appear. Alright. It's pretty good. Go back to the table and make sure you've written all of these digits down. I don't think we're done yet though. Oh, we've had those digits already. Here we go. Alright, so in that gray box, start writing. Do you see any patterns of numbers? Do any patterns repeat? Wow. Alright, wait, I'll pause. I don't think you're caught up to me yet. Imagine if you had to write all of these numbers down. This is just for the square root of 2. You got to do the square root of 3, square root of 5, square root of 6. And that's just the first million digits. Turns out that this number never ends. And at no point is there a pattern. It never ends. And there's no pattern. It never ends, and there's no pattern. These are irrational numbers. Square roots of non-perfect squares, like 3, 5, 6, 8, 10, not like numbers 1, 4, and 9. Square root of those are nice, simple, easy numbers, 1, 2, and 3. Alright, I think we've accomplished the first point. So let's now move on to the second. Turn this worksheet over. How are we going to do this? Let's start with the square root of 14. So here's a basic number line you've looked at the front of your math class for years. Notice there's no decimals or fractions. These are the numbers you learned to count when you were a very little kid. We call them the counting numbers or the natural numbers. But now above these, I've written numbers that are equivalent to them. Another way to say 10 is the square root of 100. 7, the square root of 49. Let's see, in between the square root of 1 and the square root of 4, remember we found the square root of 2 and the square root of 3. So in between all these numbers on the top portion of our number line, there are many other irrational numbers. The square root of 14 must be one of them, because it's a decimal that goes on forever and never repeats. All right, what is the square root of 14 if I can't use a calculator? Where does it go on this number line? Well, I know that the number 14 is between 9 and 16, so the square root of 14 must be somewhere between 3 and 4. Let's figure out exactly where it is, or at least round it to the nearest tenth. So I'm going to zoom in on just this portion of the number line. Now in between 3 and 4 there are other numbers. They're just fractions or decimals. Like notice this hatch mark right here. That's about 3.5. Square root of these numbers, the square root of 10, square root of 11, and the square root of 14 must lie somewhere between the square root of 9, 3, and the square root of 16, 4. So I'm just going to line them up in order. Now I'm going to count how many steps it is from 3 to 4. 1, 2, 3, 4, 5, 6, 7. 7 steps to get from 3 to 4. And the square root of 14 is 1, 2, 3, 4, 5 steps. 7 steps altogether. Square root of 14 is 5 steps of the way there to get all the way from 9 to 16, or the square root of 9 to the square root of 16. Now I started with a tough example because I don't know what 5/7 is, but it's about the same as 6/8, probably a little bit smaller because it's further from 1. 6/8 is 0.75. Since 5/7 is slightly smaller, remember I'm just estimating, I'm going to approximate that at 0.7. So the square root of 14 is about 7/10 of the way between 3 and 4. Let's try another example. What is the square root of 54 rounded to the nearest tenth? Well, it always helps to remember the perfect squares. I'm just going to make a list up here at the top. Now, I think I can stop. I know the square root of 54 must be somewhere between the square root of 49 and the square root of 64. The square root of 49 is also 7, at the other end of my number line. Alright, number 8. So now I'll start to list my numbers in between here. Quickly realize that I'm going to run out of room before I get to the square root of 64. So I'll just pretend that there are radicals there now. But still, I think I'm going to run out of room. Try to squeeze them in and it just starts to get ugly. Wait a second, why do I need to write every number anyways? Can't I just count how many steps it is from 49 to 64. Okay, 15 steps to get from 7 to 8 using square roots. Now 49 to 54 is 5 steps. So it looks like 54 is 5 of 15 steps to get from the square root of 49 to the square root of 64. We're 5/15ths of the way there, which is 1/3. So rounded to the nearest tenth, the square root of 54 is 7.3. Easy, huh? Your turn. On the second page of your worksheet, there are 6 problems for you to estimate. Draw a number line. Count how many steps it is between the perfect square on either side of 12. Let's see this. Square root of 12 lies between the square root of 9 and the square root of 16. What's the perfect square that's a little bit smaller than 72? And what's the next perfect square after 72? Good luck.